All right, so we're going to look at simultaneous equations again, but this time one of the equations will be linear and the other will be nonlinear. So the concept behind this is I'm not going to say it's straightforward, but high level. Here I'm going to draw, let me draw up that's a Cartesian plane. So we'll have y-axis and x-axis. So we'll have something like say a parabola curve, right? And then we'll have something like straight line. So I have a straight line. So this will represent your nonlinear, because of course it is a curve. And then this is your linear. If you notice, they meet at 2 points, here and here. So they have two set of solutions, right? You have this one, and you have this one. I guess I could call this x2, y2, and this x1, y1, right? So this would be what's happening. So if I look at a question now, if I find a question, try to find a simple one. All right, so far none of them don't look so simple. We'll just have to choose one. All right, let me see. All right, check this out. So we have 3x plus y equal 14. So obviously this is a linear equation. Look at the exponent. Power of 1, this power of 1. So straight linear. Then check this out now. We have 2x squared minus xy equal 3. So to do a question like this, we can't do it like how we did the ones we did before, the pair of the pair linear equations, right? For this one, you have to use a substitution method, which is to make x or y the subject of the formula for the linear equation, and then substitute it in the nonlinear equation, right? Of course, some people could say, you could substitute the nonlinear into the linear. I've never tried that, but it should work. But it appears easier if you substitute, make x or y the subject of the formula, and then substitute in the nonlinear equation. So this is supposed to be 2. The equation 1, equation 2. So I'm going to make y the subject of the formula here, because it's easy, right? I just need to, subtract 3x from both sides. So I'm going to making y the subject in equation 1. So this is y equal 14 minus 3x. Now you may ask, sir, what do you mean by make y the subject? It just means just rearrange the formula in such a way that y is by itself on one side of the equation. And all you would have to do here is to subtract 3x from both sides, and you get y by itself. So after you have achieved that, then you substitute y equal this thing, y equal 14 minus 3x. I could also label this equation as equation 3, and then refer to it here somehow. So substitute y equal 14 minus 3x into equation 2. right, into equation 2. Now, of course, you could not substitute it back into equation 1 because it's equation 1 you did use to come up with this right here. So you can't substitute it back in itself. Wouldn't make any sense. So you make the substitution now. It's all right. Let me do it. Hold on a second. Let me see if I can actually do this. Hold on a second. All right, so let's make a substitution. So wherever we say y, we're going to put 14 minus 3x. So we'll have 2x squared. So x, and then we say y now. We're going to put 14. Notice that I put a bracket at Jodos. I don't just put 14 minus 3x like that. I make sure I put it inside a bracket because I want to multiply whatever is outside of the bracket by whatever is inside the bracket fully, right? If I don't put it in a bracket, then I run the risk of just multiplying it by the first term beside the x, probably just multiply it by 14. So we simplify now. So we multiply it out and simplify. So that was 3, okay. So this becomes negative 14x, and then this becomes a positive, negative times negative positive 3x squared equal 3. Now, if you look carefully, you notice you can simplify by adding 2x squared and 3x squared to give you 5x squared. This becomes minus 14x. And then the next move is to subtract both sides, subtract 3 from both sides. This gives you equals 0. Now you may say, sir, why you do that? Because what you have here, if you recall from earlier lessons, this is a quadratic equation. So what you do in order to solve a quadratic equation, you want one side to be 0. You want to put all the other terms on the other side and have it equal 0, and then you solve for the x values in this case. So if you remember the whole AC method, where we say, all right, we look at A times C. So 5 times minus 3 is minus 15. And then we try to find factors of minus 15 such that when we add it, we get minus 14. So if we look at this, we notice that minus 15 plus 1 is minus 14. So that's straightforward. And as well, minus 15 times 1 is minus 15. So minus 15 and 1 are the candidates to use, right? So this is, my bad, not 15 there. All right, so this is 5x squared. Then we're going to we can put minus 15x plus x minus 3 equals 0. So we're replacing, we know to this already. We're replacing minus 14x with minus 15x plus x. So nothing new right here. Nothing new under the sun. All right. So we'll factorize now by pairs. So 5x on the outside, that's the highest common factor, x minus 3. Over this side, 1 would be the highest common factor. So you put the 1 on the outside, x minus 3 equals 0. So x minus 3 is common, and then you put the 5x plus 1. Supposed to be a plus 1 equals 0. So either x minus 3 equals 0 or 5x plus 1 equals 0. So as you can see, x is equal to 3 right here. And of course, if you solve for this, you'd have minus 1, and then you'd have to divide both sides by 5. So x is equal to minus 1 over 5. Right? So what have we?
Sir,
Yeah?
um, could you go back a little bit to when you reach the 5x square minus by the 14 minus by 3? When I say you minus it by 3 there.
Where? Right here, so? This line?
Yes, when they circle the 5x right there.
This line?
I did have to move. Yeah, so you can
Okay.
explain a bit how.
All right. So the 2x squared plus the 3x squared, we know that we get 5x squared. We care about the 14, the negative 14x, nothing new. And then the 3 over here, we subtract 3 from both sides. So this becomes 0, and then the minus 3 comes here, right? So we'll have 5x squared minus 14x minus 3 equals 0. And we had to do that because in order to solve the quadratic equation, that's how we set it up. We have to have it equal to 0, right?
Oh, so you
So
get the 15. Oh,
the 50, so you have to remember these things, the 15. So in order to get the middle term, we say 5 times minus 3 is minus 15. 5 times minus 3 minus 15. And then we use factors now of minus 15 to determine what the middle term should be. So if you look at the solving quadratic equations videos, we go through this
okay.
extensively.
Oh, so you use with right here now the 14x with the 3, the one with the equation here. You just work out where you get here. Forget the 15.
Yeah.
Oh, okay.
So just go back through the videos, and you will see that once you have a coefficient other than 1 here, you have, something greater than 1, less than 1, as long as it's not 0, or else it wouldn't be a quadratic equation. But you said this times this to get the 15, and then you use that now to determine the factors that are going to replace this negative 14, the middle term. And we found that 15, so 15 can go into 15, of course, and 1 can go into it. And when you add them, you get minus 14. Right? And so we reach right here now, going through, just doing a, factorizing here, boom, boom, boom. We know all of this already. We reach here now, x equal to 3, or x is equal to minus 1 over 5. Now, to show you where we are, remember where I put this little diagram up, right? Like a graph. So what we have just done was to find the x values. You see that? So we have x1, x2. So we need to
Yes,
find
sir.
the corresponding y values now. So when you look, we say, all right, remember when we were doing the simultaneous equation with the two linear equations, what we did was to substitute back into one of the equations to find what the other variable is. So we know that x equals 3. So we need to now substitute back up here, ideally into equation 1, to find what the y values are. So let us write back equation 1 down the bottom. So it's 3x plus y equal 14. So 3x plus y equal 14, right? So that's equation 1. So we say, okay, substitute sub x, or better yet, I prefer to say it this way. I prefer to say it. So substitute, you're going to substitute, Well, a nice way to say it is when x equal 3, we have um, So you have y. So we have 9 plus y equal 14. And y is now, what, 5. Cool. So we'll subtract 9 from both sides. So when x equal 3, we have this situation, right? You can either tell them that you're going to substitute x equal 3 into equation 1, right? So I can probably do it in the next way, next for the other one. So we need some space. So again, so when this time, when x is equal to 1 over 5, and then if you want, say substitute, sub into equation 1. So I put this in brackets. So we have 3, 1 over 5, y equals 14. Put a little. So this is just negative 3/5 plus y equal 14. So y is equal to 14 plus 3 over 5, right? Which you can say it's 14 and 3/5. Some people may not dig that, or you can find, you can multiply the top and bottom by 5 and then add across and get an improper fraction, whichever way. Can try. I think you would get 70 if you multiply 14 by 5. Yeah, that sounds right. So you'll have 70 over 5, 3 over 5, and this gets just 73 over 5, right? But I don't know. I don't like how that looks. I would probably just work with a mixed fraction and say, all right, this is just 14 and 3/5, right? And, forget about down here. So that would be an answer, right? So you have, let me just fix this up. So I'll work with a mixed fraction. All right. So what can we say now? Let me try and find some space. Use the bottom. So we have x equal 3, y equal 5, and x equal 1/5, and y equal 14 and 3/5. Cool, and this is negative 1/5, to be clear. And if you want to put when, so when x equal that, and when x equal that, you get that. So when I look up here, just to remind you what we just did, more to the left, of course. So again, we found the solutions where the two lines or the two graphs intersect. The nonlinear curve and the linear line, right? The line. So the line and the curve where they intersect. So that's what we just did. So we got the coordinates, right? Or we got the solutions where they intersect. And that is how it's done. So I'm going to leave it right there. I'm going to upload this one, and this and the other video you can use to help you to do the homework. So yeah, that's it for today's class. If you have any questions, you can just Can talk after class basically.